Hi everyone. Today we're going to talk about linear equations written in a different form. You're used to talking about linear equations in slope-intercept form. That's the y equals mx plus b that you're used to. Today we're going to talk about what's called standard form. And standard form looks like this. Okay? So actually right here where it says standard form of a linear equation, we're going to jot this down. That ax plus by equals c. That's what's called standard form, where you have the x and the y together on one side and the constant over on the other, okay? And in this form, the a, b, and c would all be numbers. So think about those equations that we just finished with in the last lesson. The chemistry one, for example, 0.35a plus 0.45b equals 18, something like that, okay? That's an equation written in standard form. Now, technically, I'm lying to you right now because for it to be called standard form, true standard form, your a, b, and c all need to be integer values, meaning no fractions or decimals. But all those ones that we did that involved fractions and decimals, we could have really easily multiplied through by 10 or 100 or, some common factor to turn them into standard form. So I'm not going to stress about that too much. What I really want you to know is that this is another very common way that linear equations can be written. I'm going to call your attention down to these examples down here. We'll get to these in a second, but this one here is written in slope-intercept form. You're used to that one. Y equals mx plus b. Okay, you've done that one a lot. But then if you look at this one is written in what's called standard form. Okay, it's still linear. It's just a different form of the equation. So that's kind of what we're focusing on today. All right. Before we can talk about these, though, I want to talk about your intercepts, okay, and what it means to be an intercept. So let me draw you a quick picture here. So if I graph a line, any line, I don't care how you graph it, okay? If I graph a line on a coordinate plane, typically it has two intercepts. It has the y-intercept, and you're used to that because in slope-intercept form, the b value is the y-intercept. And you have the x-intercept, okay, the place where it crosses the x-axis. So the intercepts are the places where the line crosses the axis. And so what we're going to focus on today is what's unique about this point here and what's unique about this point here. And the thing I want you to take away is that anywhere on the y-axis, which is where the y-intercept will always be, anywhere on the y-axis, we know that the x value is equal to 0. Does that make sense? That the x value measures how far left and right your coordinate is. And so if you're right on this y-axis, you haven't moved left or right at all. So you're going to be at 0 on the x-axis anytime you're on this y-axis. Okay? At the x-intercept, similarly, we know that y is always equal to 0. Because anytime you're on this line here, you haven't moved up or down at all. So your y value is always going to be 0. So even if I graphed another line, let's make my line go, I don't know, this way this time. Okay? And I looked at my two intercepts. At this point here, let me grab my other color. At this point here, that's my y-intercept. And if I were to find the coordinates, I know that my x value would equal 0. And at this point here, that's my x-intercept. At this point, I know the y would equal 0. Because anywhere along this line, y is equal to 0. Okay? And anywhere along this line, x is equal to 0. So the big takeaway there is that always, always, always with a linear equation, at the x-intercept, I know y is equal to 0. And at the y-intercept, I know x is equal to 0. And I'm going to ask you that question 7,000 times between now and your next test. Okay, so just be ready for that. What that means for us, the reason is that's important, is I'm going to be asking you to find x and y intercepts. And your equations are going to be written all different ways. So for example, in this first example, y equals negative 5x plus 2. You could probably tell me the y-intercept right now, right? And you should be able to. The y-intercept is going to be 2. Okay, because it's in y equals mx plus b form. But what's the x-intercept? Well, if I look back at what I just figured out, at the x-intercept, I always know y is equal to 0. So to find that, and you are going to want to write this down, to find the x-intercept, I'm going to plug in a 0 for y. Always. Doesn't matter what your equation looks like. That's your strategy. Okay? So I'm going to say 0 equals negative 5x plus 2. And then I'm going to solve that. Gosh, I wish I had left myself some more room here. Okay, there we go. I just shrunk it up some. So again, looking for the x-intercept, y is equal to 0. You'll see that I put a 0 in place of y in the equation. So I took this original equation, put a 0 right there, and now I'm going to solve it. So I'm going to subtract 2 and subtract 2. So I get negative 2 equals negative 5x. Let's divide by negative 5. And I think we're going to get 0.4. X is equal to 0.4. Positive, because negative divided by negative is positive. And actually, I don't care if you make that a decimal or a fraction, okay? Intercepts, it doesn't matter. Slope, I always tell you to leave as a fraction, but intercepts, I don't care, okay? Now, again, I would hope that you could look at that equation and tell me the y-intercept right off the bat. But let's suppose you couldn't. Let's suppose that somehow you forgot y equals mx plus b. Well, I know then that the y-intercept, x has to equal 0. Okay? So to find that, I'm going to put a 0 in place of x this time. And here's what that's going to look like. Y equals negative 5 times 0 plus 2. Well, this time I don't really have to solve because y is already by itself. I just have to evaluate what this is equal to. Negative 5 times 0 is just 0, and 0 plus 2 is 2. So now I know that y is equal to 2. Which again, hopefully you already knew that because that's my y-intercept and slope-intercept form. But there's my x-intercept, there's my y-intercept. By the way, remember that your intercepts are two separate points. Think of the picture that we drew up here. Okay? Your intercepts are 1 point here and 1 point here. It's not one coordinate put together. A lot of the times I see people do all this and then say, oh, well, then the intercept is 0.4 comma 2. That's not one coordinate. My x-intercept should technically be written as, let's see, 0.4 comma 0. And my y-intercept should be written as 0 comma 2. Okay? And again, pay attention to the placement of the zeros there. If this is the x-intercept, I want the number in the x spot. This is the y-intercept, so I want the number in the y spot. Okay? So now look at your next one. We could rearrange that to slope-intercept form. But to find the intercepts, I don't really need to. Okay? And in fact, I think it's easier not to. So, again, my strategy, if I'm looking for the x-intercept, what do I know? I know that y is going to have to equal 0. So I'm going to put a 0 right in place of y. So I'm going to say 5x minus 4 times 0 equals 30. Okay, well, 4 times 0 is just going to cancel. So I'm really just left with 5x equals 30. And if I divide by 5 on each side, I get that x equals 6. And that's my that's my x-intercept. Again, if I wanted to think of that as a coordinate, it would be 6 comma 0. To find my y-intercept, at the y-intercept, I know that x is going to equal 0. So same thing, except I'm going to put a 0 in place of x this time. 5 times 0 minus 4y equals 30. This is going to cancel. The only thing you want to watch out for in this one is remember that that's a negative 4y. Okay? So when I go to solve this, now I have negative 4y equals 30. And I believe when I divide that one, I'm going to get negative 7.5. So that means as a coordinate, my y-intercept would be 0 comma negative 7.5. Okay? And honestly, what I do with these ones usually is not even write out all this work. Okay, I would expect that probably you could do that one without showing so much work. And here's how, and I'm going to demonstrate it here. It'll probably make more sense the first time we do one of these on the board. But if I know that my x is going to be a 0, for example, if I'm looking for my y-intercept and x is a 0, I know that this whole thing is going to cancel out and be a 0. So I just kind of cover that up in my mind, or even with my finger, and then I see negative 4y equals 30, and then I just divide. Okay, either in my head or on a calculator. Same thing if I was looking for my x-intercept. I would cancel out the y, and oh look, 5x equals 30, so divide and x equals 6. That didn't work out quite so easily up here. I had to do this solving, but when it's written in this form, the intercept should be quick. The intercept should be easy, which means if I hand you one of those equations and say go graph it, you could go through the process of rearranging it and putting it in slope-intercept form to graph it. Or you could say, well, I can find the intercepts really easily. Okay, my x-intercept is 6, so I'm going to take a walk down here to 6 and make a dot. Oh, I just lost count, sorry. Okay, so put a dot on the x-axis at 6, and then my y-intercept is negative 7.5. So I'm going to go 1, 2, 3, 4, 5, 6, 7.5. It's going to be right in the middle here. Sorry, it's hard to get real accurate with a stylus. And then just connect your dots. So you don't have to worry about rise over run or anything. You get your two intercepts on there and connect them, and you're good to go. So I really think that's the easiest way to graph something like this. Okay? Now, there's going to be a lot of students, I get these students every year who say, no, I would rather just put it in slope-intercept form and graph it that way. That's totally fine. Okay? Totally your choice. But this whole process that I just went through could be done without really writing anything down, without having to go through any work, really. Okay, so I'm just trying to save you some time there.